Welcome to the Explainer. Today, we're jumping right into one of the most massive challenges in modern software development, which is engineering AI coding agents. Look, if you've been working anywhere in the tech space lately, you know these AI coding assistants are literally everywhere. And yeah, they're incredibly powerful and lightning fast, but they bring this persistent, incredibly frustrating struggle for developers: reliability. So we're going to break down exactly how to take these highly capable tools and transform them from unpredictable wildcards into rock-solid production-ready assistants using a concept called harness engineering. Now, this brings us to a really fundamental question, and it's honestly one that's probably haunting your own development cycles right this second. Why do highly capable coding agents still fail? I mean, we're talking about top-tier, state-of-the-art models here like OpenAI's Codex or Anthropic's Claude. These models are absolutely brilliant. They can write complex algorithms in a matter of seconds. Yet, you ask them to build out a full feature, and suddenly they completely lose context halfway through, or they start hallucinating phantom variables, or they just totally derail during complex tasks. So why exactly does this happen when the models themselves are supposedly so smart? Well, there's this widespread myth in the industry right now that the solution to our AI problem is simply making the model smarter. We all kind of think, if we just wait for GPT-5 or the next massive update to Claude, all our problems are just going to disappear. But the reality? The reality is entirely different. Think of it like a worker versus manager analogy. You can hire the most brilliant, genius-level junior developer in the world. That's your AI. But if you don't give them a rigid management system, crystal clear requirements, a proper desk to work at, and a strict QA process to review their code, they're either going to build the completely wrong thing or just get totally distracted. What we actually need isn't a smarter AI. What we really need is to establish a closed-loop working system around the AI we already have. To get us there, here is the roadmap for today's Explainer. We'll cover 1. Why capable agents fail. 2. Defining the harness system. 3. Objectives and initialization. 4. Execution and runtime feedback. 5. Verification and autofixing. And finally, 6. Clean state and handoff. All right, Section 1. Why capable agents fail. Let's explore the exact limits of raw AI intelligence. When you let an AI agent just run loose without proper boundaries, you're going to hit some very specific, very painful roadblocks. The first major issue is that they completely lose continuity on long-running, multi-session tasks. Like if a task takes more than one single prompt to solve, the agent basically forgets what it was even doing in step 1 by the time it reaches step 5. Second, and let's be real, this is truly infuriating, they declare victory way too early. The agent writes a quick script, confidently spits out done, but the code hasn't even been tested, let alone integrated. And finally, they overreach and underfinish. They try to rewrite your entire code base instead of just fixing the specific bug you asked them to fix, which leaves you with a half-broken mess. Moving on to Section 2, defining the harness system. This is where we constrain all that chaos. So, according to the foundational engineering theories we're looking at today, a harness is defined as a closed-loop working system. It utilizes systematic environment design, state management, verification, and control systems to make agentic coding tools reliable. Now, I really want you to focus on that definition for a second. Notice what's missing. There is zero mention of prompt engineering for better intelligence. A harness does not make the AI smarter. It just gives it a reliable, structured framework so it can actually succeed. It's basically the rails that keep the train on the track. So, what does this actually look like in practice? Well, this right here is the macro journey of a task moving through a closed loop. This is the core mechanism of harness, and it's going to serve as our blueprint today. Every single task has to go through these exact stages: establishing a clear objective and initializing the environment, then actually running the tasks, and crucially, absolutely crucially, verifying and queuing the output. If you skip any one of these steps, the loop breaks and the agent fails. Simple as that. Okay, Section 3, Objectives and Initialization Phase. Let's look at the starting line. You see, the biggest mistake developers make is just opening up a prompt window and vaguely asking the agent to build a feature. But in a harness system, we establish a rigid starting line using two critical components. First, we use an agents.md file. And to be clear, this isn't just some simple prompt. This file establishes explicit rules, strict boundaries, and deep context for the AI, right inside the repository. It tells the agent exactly what it's allowed to touch, and more importantly, what it isn't. Second, we use an init.sh script. This handles a dedicated initialization phase. It preps the environment, installs all your dependencies, and ensures the workspace is perfectly primed before the AI even attempts to write a single line of logic. We are constraining the behavior right out of the gate. Section 4. Execution and runtime feedback. What happens when the agent actually gets to work? Running tasks has to be a two-way street. It requires the tasks handled by the AI agent to directly pull in runtime feedback generated by command line interfaces and logs. When the AI agent writes code, it shouldn't just be throwing it over a wall into the dark. A proper harness routes the system's actual runtime feedback directly back to the agent. So, if there's a syntax error, the agent sees the log. If a build totally fails, the agent sees the CLI output. This makes the entire process totally observable and debuggable for the AI. It essentially gives the agent eyes to see the immediate real-world results of its actions. Section 5, verification and auto-fixing, because seeing the feedback is one thing, but acting on it is the real magic. This verification process right here, this is the beating heart of a reliable closed-loop system. When the agent thinks it's done, it spits out an output. But in a harness, the agent doesn't get to decide if it's finished. The test suite decides. If the agent's output fails the full pipeline test suite, the harness instantly triggers an auto-fix loop. It takes those specific test failures, feeds them right back to the agent, and forces it into self-reflection. The AI literally has to fix the code and try again. It is trapped in this loop until the code is completely exactly right. Only when the output definitively passes the test suite does the harness finally step in and mark the code as completed. Finally, Section 6, clean state and handoff. We can't just leave a massive mess for the next session. You can't just have the agent stop working and abruptly walk away. A professional harness ensures proper cleanup and handoff. And according to the source framework we're exploring today, this is often managed via a state file, something like claudeprogress.md. This file basically acts as the repository's memory bank. It documents exactly what was completed, exactly what state the code is currently in, and leaves everything perfectly clean for the next session. This is how you maintain continuity on those really long-running projects. By saving the state, the next time you boot up the agent, it just reads that progress file and picks up right where it left off. That completely eliminates the agonizing multi-session amnesia we were talking about earlier. So let's take a step back and recap what we've actually accomplished by putting all these pieces together. By establishing a harness, you've mastered constraining agent behavior with explicit rules using that agent's file. You're maintaining crucial context across long, multi-session tasks. You are actively stopping agents from declaring an early victory by stripping away their right to just say, done. You're rigorously verifying all work with full pipeline tests and those auto-fix loops, and you're making the runtime entirely observable. Mastering these components is literally the difference between using AI as a fun little toy to write snippets and using it as a serious production-ready assistant that can actually build reliable features for your team. Which leaves us with one final, pretty critical question for you to ask about your own development environment. Is your AI agent running wild, just hoping it gets things right based on how quote-unquote smart it is? Or is it securely harnessed within a closed-loop system that actually guarantees success? Look, implementing this level of engineering definitely requires a shift in mindset, moving away from just tweaking prompts to actually building systems. But the reliability you get on the other side, it is an absolute game changer. Thanks so much for joining me for this explainer, and I highly encourage you to go take a look at your current repositories and start building those boundaries today.